Hey guys, welcome back. In this video, we are building a real-time data pipeline that brings sales, product and customer data from a production database into a data warehouse using Spark, Kafka, Debezium and Snowflake. And yes, I will show you a full demo of how it works at the end. This will be a short, clear and packed with value. So stick around. So the first question, what data are we moving? Here is what Joya's team need to track in real time. Product table, customer table and sales table. This data lives in the production database, your PostgreSQL, MySQL or any other OLTP system. Now the big question, how do we move this data without hammering the database? Change data capture is our answer. It reads the bin log of your database, capturing insert, update, deletes in real time. Tools like Debezium, Airbyte can stream these changes without running heavy query. Alright, let's begin with step 1. Streaming changes from the source database into Kafka. We start by capturing real-time changes from our source database. In this case, the PostgreSQL. To do that, we use CDC tool like Debezium or Airbyte with Kafka support. Debezium listens to the changes, inserts, updates or delete and convert them into a streams of event. These changes are then published to Kafka topics using Kafka Producer. Now you might ask, why Kafka? Kafka is not just a message broker, it acts as a highly available buffer for all real-time changes. It guarantees order, scalability and fault tolerance. Even if a downstream system crashes, Kafka ensures no data is lost. You can replay events, scale out and process data reliably. So in the first step, we have successfully turned raw database changes into real-time fault-tolerant system, ready to be processed by the next stage in our pipeline. Now that our data changes are flowing through Kafka, it's time for real-time processing. We use Spark structured streaming to read directly from Kafka topics. From here, Spark can continuously ingest events, transform them, and even enrich the data on the fly. You can apply transformations, aggregations, joins, and even windowed operations, like tracking sales over 10-minute intervals, all in real time. So why do we use Spark? Spark is built for high-performance distributed stream processing. Join data from multiple streams, apply complex filters, or use windowing for time-based aggregation. It scales horizontally and handles massive throughput, all while giving you flexibility of writing familiar SQL-like logic. So with Spark plugged into Kafka, you now have a powerful stream processor that can clean, enrich, and reshape your data in real time, setting the stage for loading into your data warehouse. After processing the data with Spark, the next step is to push it into the data warehouse. Spark can write the transformed data directly into the warehouse of your choice, whether it's Snowflake, BigQuery, or Redshift. Alternatively, you can use a tool like Airbyte to sync data from Kafka into the warehouse, especially if you prefer managing ingestion through connectors. Another approach is to first land the processed data into a staging area like cloud storage S3 and then load it into the warehouse from there. This gives you flexibility in how you manage your data flow, whether it's direct ingestion for a speed or a staged approach for a better control and validation. Once the data is in your data warehouse, you are ready for the final step, powering the real-time dashboard. With the warehouse continuously receiving fresh data, you can build dashboards that reflect live updates and key business KPIs. Tools like Looker Studio, Tableau, or Power BI can connect directly to your warehouse and display real-time insights. Whether it is tracking sales trend, identifying top performing products, or analyzing customer behavior as it happens. And just like that, your data journey goes full circle. From raw change events in a database to actionable insights on dashboard, all in real time. We are almost ready to jump into the live demo. So if you have been waiting to see this pipeline in action, hang tight. It's coming up soon. Let's quickly talk about why change data capture or CDC is such a game changer in modern data pipelines. First, real-time sync without full reloads. Transactional ETL jobs often reload entire table on a schedule. That means scanning millions of rows even if only few change. CDC flips this, it captures just the delta, only what changed, and streams it in near real time to your data warehouse. Next, less load on source system. Instead of hitting your production database with heavy queries, CDC needs from transactional log like MySQL's binlog or PostgreSQL. This means no disruption to your app's performance even during peak traffic. Then there is lower cost and faster pipeline. Because you are moving only the change data, not full tables, pipelines are lighter, faster, and cheaper. Especially important when you are paying for every gigabyte in the cloud environment. It also means accurate and timely reporting. Dashboard reflects the freshest data, ideal for monitoring revenue, user behavior, or inventory level in near real time. And finally, CDC is critical for event-driven architecture. It enables downstream systems like recommendation engine, fraud detection, or alert system to react instantly to what's happening, all without overloading your infrastructure. Okay, now let me show you how it works in real. It's show time. Alright, let's quickly dive into the demo of our complete real-time data pipeline. To keep things simple and reproducible, everything will be running inside the Docker container. First up, we have a Postgres container which acts as our source database. A Debezium connector container to capture changes from Postgres. Apache Kafka which will receive and stream the captured data. And finally a Spark container for processing these events. Let's look into the Postgres database. Here I have set up 3 tables: customer, sale, and product. These are the exact tables we want to ingest into our data warehouse. Let's open the sales table. As you can see, I have already inserted some sample record here. This is the data our pipeline will ingest in real time. Now that we know what our data looks like, let's take a quick look at connector. I have already created one using the simple curl command. This command sets up a Debezium connector that listens to a specific table as defined in its config and pulls data changes from there. Let's see the connector configuration in the config I specified. The database host and port, the tables we want to capture the changes from, the plugin used to capture changes, and the Kafka topic where this event should go. Let me show you the connector status. As you can see, it's up and running, which means it's actively pulling the data from the Postgres sources. Moving on to the Kafka. I have three topics created. One for customer table, one for product table, and one for sales table. Let's start a Kafka console consumer so we can automatically see the data streaming in real time into the topics. Now let's talk about the Spark application. I have written a simple Spark streaming job that reads from the appropriate Kafka topic, transform the data, and write it into Snowflake, our target data warehouse. Here is how the code works. First, we create a Spark session, then define the schema for incoming Kafka data. Then I read the stream using read stream as a stream. Apply some basic transformation like parsing and typecasting. And finally, we clean the data and write it to the Snowflake. This job runs continuously and writes each incoming micro batches to the destination. Before we run the Spark job, let me quickly show you the Snowflake tables. I have created three tables: customer, product, and sales, each with the same schema as in the Postgres source. This allows us to store the incoming data as it is. Let's inspect the current state of the sales table. It currently holds 18 records. I have also created a sample dashboard in the Snowflake. It shows the total number of sales and total number of amount. This dashboard should automatically refresh when new data arrives without us lifting a finger. Okay, let's run the Spark job first. Now everything is running, our entire pipeline is up, it's show time. I'm going to insert three new records into the Postgres table. Let's see what happened in the Kafka, Spark, and Snowflake. I have just inserted the records. Let's check the Kafka first. You can see the exact same data we inserted in now streaming into the Kafka topic. This is the raw payload being passed along. Now over to Spark. The Spark job picks up these new events and process them immediately. Now let's head to the Snowflake. If I refresh the sales table, you will notice that the record count has been increased from 18 to 21. The new data is already here. And finally, let's refresh the dashboard. The total sales and record counts have automatically updated, reflecting the new insert. And that is the power of real-time data pipeline. You insert data at once and the entire pipeline from source to Kafka to Spark to Snowflake handles everything. This is real data engineering in the action. This was just a bird's eye view. If you want me to build this pipeline step by step from setting up Kafka to streaming with Spark, drop a comment below and don't forget to subscribe so you don't miss it. We have now connected the foundation. Your structured data is flowing into the warehouse in real time. But what about behaviors? Clicks, scrolls, abandoned carts? That's next. In the following video, I will show you how to capture clickstream data and marry it with your structured data for a complete customer intelligence. If this video helped you, consider subscribing and don't miss the next part. We are going from structure to behavior. That's where the real gold is.